Imagine waking up without an alarm, no phone buzzing on the nightstand, no traffic sounds filtering through the window, no schedule to check, no emails waiting, no meetings to prepare for. Instead, you open your eyes to the soft grey light of dawn filtering into a rock shelter. The air carries only the faint whisper of wind across ancient stone, and beyond that shelter lies a sky so vast and untroubled that time itself seems to pause. In that stillness, the universe reveals its quieter side, a place where moons glide in endless, soundless arcs and rings shimmer like frozen rivers of light. What if we could linger there for a while, letting the silent, majestic dance of those distant worlds unfold at its own unhurried pace? Picture the gentle pull of gravity guiding icy bodies around gas giants, each orbit a slow, graceful waltz that has continued for billions of years without a single interruption. No collisions announce themselves with noise, no atmospheres carry the roar of storms across empty space. Only the elegant geometry of motion remains, hidden in the folds of our solar system's most remote corners. This journey we are about to share will take us through those hidden corners, from the familiar glow of our own moon to the shadowed realms where captured worlds trace unpredictable paths and rings of dust and ice catch the faint sunlight like delicate veils. Along the way we'll meet moons that may once have wandered freely before being gently drawn into new families, and we will consider how slight gravitational nudges could have shaped entire systems over unimaginable stretches of time. Every fact we touch upon opens a small window into possibilities rather than certainties, because the farther we look, the more room there is for wonder about how these quiet arrangements first came to be. Curiosity grows naturally here, doesn't it? One moment we're contemplating the steady light of a single satellite, and the next we find ourselves imagining what subtle forces might have tugged an entire family of moons into perfect resonance. The questions multiply the deeper we travel, and that is part of the quiet pleasure of turning our thoughts outward. If you're listening right now, I would love to know where you are and what time it is for you. Drop a comment and tell us your corner of the world. It is always interesting to feel connected across the globe and see how many different moments are sharing this same gentle drift through space. Whether the sun is just rising where you sit or the stars have already claimed the sky, we are all turning together beneath the same quiet orbits. So settle in, let the ordinary noises of the day fade a little further, and allow yourself to drift along with these moons and rings. There is no rush, only the slow unfolding of stories written in silence and light. Our own moon has always been the gentlest companion in that vast stillness we have been drifting through, the one light that has hung above every quiet shelter and open plain since the first eyes turned upward. Its story begins not with certainty but with the patient unravelling of clues carried back from its silent surface, clues that suggest it may have formed in a colossal encounter when a young Earth met another wandering body in the early solar system. The leading picture painted by those ancient collisions describes a glancing blow that hurled molten rock into orbit, where it cooled and gathered into the familiar sphere we see today. Lunar samples returned by the Apollo missions revealed a world once molten and heavily bombarded, its rocks rich in minerals that match Earth's mantle, yet strangely lacking the water and volatiles we might have expected. Those same rocks told of an early magma ocean that solidified into the highlands and later allowed darker basalts to fill the great basins, each fragment a quiet record of heat and violence that eventually gave way to the calm we now witness. Yet the moon did more than simply arrive. It stayed and shaped the very conditions that allow life to unfold here. Its steady gravitational tug holds Earth's axis at a gentle tilt, preventing the wild swings that would otherwise turn seasons into extremes and make steady climates impossible across long stretches of time. Without that anchor, the poles might wander dramatically, the oceans would rise and fall in chaotic patterns, and the delicate balance of sunlight reaching land and sea would shift beyond recognition. The tides it raises each day still mix nutrients through shallow waters and keep coastlines in slow rhythmic motion, subtle forces that may have helped early chemistry find its way toward living forms. In this way, the moon becomes not just a companion but a quiet guardian whose presence has steadied the stage for everything that followed. Long before any samples left the lunar surface, people watched that same steady light and wove it into their sense of time and place. Ancient cultures tracked its phases to mark planting seasons and sacred gatherings, noticing how its face changed in predictable cycles against the fixed stars. Early skywatchers in every corner of the world recorded eclipses as moments when the familiar glow was briefly stolen, events that prompted stories of balance and renewal rather than fear once patterns emerged. Centuries later, the first telescopes turned that pale disk into a landscape of mountains and plains, revealing shadows that lengthened and shortened with the lunar day. By the time spacecraft carried humans there, the moon had already served as a shared reference point for generations, a visible reminder that the same rules of motion and light applied both overhead and underfoot. The Apollo journeys added the human element to that long observation, bringing back not only rocks but also the simple fact that footprints could remain undisturbed for ages in that airless quiet. Even now, after all those visits and measurements, the moon keeps a few gentle secrets that invite further wondering. Water ice lingers in the permanent shadows of polar craters, protected from the sun's constant glare, and perhaps delivered long ago by comets, or formed through slow chemical processes on the surface itself. These hidden reservoirs raise quiet questions about how much more might rest beneath the regolith, and what it could mean for any future presence there. Then there are the lunar swirls, pale, twisting patterns that snake across the dark plains without any obvious crater or ridge to explain them. Some researchers wonder whether ancient magnetic fields, now faded, once shielded patches of the surface from the solar wind, leaving brighter dust in their wake. Others consider whether subtle electrostatic forces or even cometary impacts could have sculpted the same features. Each possibility remains open, a reminder that even our nearest neighbour still holds room for discovery rather than final answers. As we linger with these thoughts, the moon's presence feels less like a distant object, and more like an invitation to notice how one body can steady an entire world while keeping its own mysteries intact. The same light that once guided ancient calendars now helps modern instruments map those polar ices and magnetic traces, connecting the oldest observations with the newest questions. In the unhurried rhythm of its orbit, we find a reminder that stability and surprise can share the same sky, and that the quietest companions often shape the largest possibilities. From the moment its formation set the stage for calmer seasons to the ongoing search for ice and swirls, our moon continues to offer both constancy and curiosity, a soft grey presence that has watched over the turning Earth through every age of stillness and change. As we rest with the steady glow of our own moon and the gentle pull it has kept across ages of quiet skies, other worlds invite us to notice companions that arrived not from shared beginnings, but from distant wanderings. These captured moons slipped into orbit after long journeys through the early solar system, their paths shaped by encounters that scattered bodies like leaves in a slow cosmic breeze. Their presence adds layers of motion to the stillness, reminding us that even the most settled orbits can carry traces of ancient restlessness without disturbing the calm we feel when we look upward. Consider the two small attendants circling Mars. Phobos and Deimos appear as faint irregular specks against the reddish disk, their surfaces pocked and uneven like fragments of something larger that once drifted freely. Astronomers have long wondered whether these tiny bodies formed alongside the red planet or were drawn in from the asteroid belt, their dark carbon-rich makeup and potato-like shapes suggesting they may once have travelled independently before a close passage allowed Mars to hold them gently. Yet their orbits tell a story of impermanence. Phobos circles so near that it completes a loop in just 7 hours, skimming above the thin atmosphere and raising faint tidal bulges on the surface below. Over time, those same tides are drawing the little moon inward, and in perhaps 50 million years it may break apart or spiral down, its material scattering into a faint ring or settling as new dust on Martian plains. Deimos, farther out and slower, may linger longer, yet both serve as quiet markers of how small bodies can be taken in and then slowly released again, their doomed dance unfolding across timescales that outlast any single observer yet remain part of the same unhurried rhythm. Farther out, another captured traveller circles Neptune in a direction opposite to the planet's spin. Triton moves against the flow, its path tilted and retrograde, carrying clues that it did not condense from the same disk of material that built its host world. Instead, it likely originated in the colder reaches beyond Neptune, perhaps among the scattered objects of the early Kuiper region, before a gravitational encounter pulled it inward and reversed its course. Its surface, smooth in places and marked by dark streaks and frozen nitrogen plains, hints at internal warmth that once allowed cryovolcanoes to reshape the landscape. But that same capture has set Triton on a tightening spiral. Over the coming billions of years, its orbit will decay until Neptune's gravity stretches and eventually tears the Moon apart, scattering its icy fragments into a new ring system. In this way, Triton becomes both a visitor from the outer quiet and a harbinger of future change, its backward motion preserving a memory of the solar system's more unsettled youth, while promising a gentle dissolution that will add new beauty to the rings we admire today. Astronomers distinguish these captured objects from moons that formed in place by reading the signatures left in their paths and compositions. Born-in-place moons tend to orbit in the same direction as their planet's rotation, close to the equatorial plane, and often share similar densities and surface materials with the world they accompany. Captured moons, by contrast, frequently travel on inclined or retrograde orbits, display mismatched compositions that resemble distant asteroids or Kuiper belt bodies, and sometimes appear as irregular lumps rather than rounded spheres. These differences arise because capture usually requires a third body or a temporary slowdown, such as gas drag in a young planet's envelope, or a three-body interaction that robs the incoming object of just enough speed to stay bound. The process leaves orbital traces that cannot be erased easily, allowing modern observations to reconstruct the moment when a free wanderer became a companion. Such distinctions remain open to refinement as new measurements arrive, yet they consistently point toward a solar system that once exchanged material across wide distances rather than keeping every body neatly in its original cradle. These captured moons therefore open windows onto the early solar system's greater turbulence. In the first few 100 million years after the planets coalesced, gravitational encounters between growing worlds and leftover planetesimals could fling objects inward or outward, sometimes allowing one planet to steal a moon from another or to snare a passing asteroid during a close approach. The presence of Phobos, Deimos and Triton among the quieter prograde families suggests that such exchanges happened repeatedly, mixing material from the inner and outer regions and leaving behind the irregular satellites we observe today. Their stories invite us to picture a time when the architecture of the solar system was still being negotiated, when orbits shifted and small bodies found new homes without fanfare. Yet that same history also underscores the patience of the present arrangement, where these adopted companions now trace their paths in the same untroubled silence that surrounds our own moon. As these thoughts settle, the captured moons emerge not as disruptions but as gentle additions to the larger stillness, each carrying fragments of distant origins while contributing to the slow evolution of rings and orbits yet to come. Their eventual fates, whether spiraling inward or breaking into new structures, continue the same cycle of arrival and quiet transformation that has shaped the solar system since its beginning, offering fresh reasons to linger with the night sky and wonder what other wanderers might yet find a home among the planets we know. As these adopted companions settle into their long, untroubled paths, a different family of moons draws the gaze outward, one that has remained bound to its planet since the earliest days of the solar system. 4 bright points of light, noticed one winter evening through a simple tube of lenses, quietly altered how anyone looking upward could picture the arrangement of worlds. In 1610, when Galileo turned his telescope toward Jupiter and recorded 4 small bodies that shifted position night after night, the observation carried a gentle yet profound suggestion. Here were objects circling another planet, not our own. That single insight invited the thought that the Sun, rather than Earth, might occupy the centre of the planetary dance, and it opened a wider view of a cosmos where many centres of motion could exist side by side. The discovery did not arrive with clamour but with patient watching, and it still encourages us to linger with the same sense of quiet revelation whenever we consider the 4 large satellites that now bear Galileo's name. These moons orbit in the same direction as Jupiter's spin and lie close to its equatorial plane, suggesting they condense from the same disk of gas and dust that gathered around the young giant. Their sizes range from worlds nearly as large as planets, down to bodies that still hold ancient records in their surfaces, and each one offers its own invitation to imagine what quiet processes have unfolded across billions of years. Io, the innermost of the 4, reveals itself as the most volcanically active place yet observed. Tidal forces from Jupiter and its neighbouring moons stretch and squeeze Io's rocky interior, generating enough heat to keep vast lakes of molten rock molten and to drive plumes of sulfur and silicate material high above the surface. The result is a landscape that constantly renews itself, with fresh lava flows covering older terrain so quickly that few impact craters remain visible. One can picture the slow, rhythmic flexing of rock and the steady outpouring of heat as part of the same unhurried rhythm that keeps the entire system in balance, a reminder that even the most energetic surface can belong to the larger stillness. Moving outward, Europa presents a strikingly different face, one whose smooth, bright ice shell hides an ocean of liquid water beneath. The same tidal flexing that powers Io's volcanoes warms Europa's interior enough to maintain that global sea, possibly in contact with a rocky seafloor where chemical energy might support simple life. Scientists continue to study the reddish fractures that cross the icy crust, the possible pockets of water that rise toward the surface, and the faint signatures that spacecraft have detected from orbit. While no one can yet say with certainty whether life exists there, the possibility lingers like a soft question in the night, inviting further gentle observation and patient thought. The very idea that an ocean might persist so far from the sun, kept liquid by the steady pull of neighbouring worlds, adds a layer of quiet wonder to the picture of moons as places where unexpected conditions can endure. Beyond Europa lie Ganymede and Callisto, two ancient witnesses whose heavily cratered surfaces preserve stories from the solar system's youth. Ganymede, the largest moon in the system, carries its own faint magnetic field generated inside a layered interior of ice, rock, and perhaps a deeper ocean. Its surface shows both dark, heavily cratered regions that record countless impacts from long ago and lighter areas crossed by grooves that hint at later geological activity. Callisto, farthest out of the four, appears even more untouched, its face almost entirely covered by overlapping craters that have accumulated over billions of years with little subsequent change. These two moons therefore serve as steady archives, their cold, quiet exteriors holding the memory of early bombardment and the slow settling of the solar system into its present calm. Their orbits remain steady, their surfaces largely unchanged except by the occasional arrival of new material, and together they illustrate how different outcomes can arise even among moons that share the same planetary neighbourhood. The Galilean moons together form a miniature system whose gravitational interactions continue to shape their paths and interiors in subtle ways. Resonances between Io, Europa and Ganymede keep their orbits slightly eccentric, sustaining the tidal heating that drives Io's volcanoes and keeps Europa's ocean liquid while leaving Callisto more isolated and therefore more frozen in time. These relationships unfold across timescales that dwarf any single human life, yet they contribute to the same sense of enduring rhythm that the night sky offers when we simply watch without hurry. Each moon adds its own chapter to the larger story of how worlds can remain companions across vast stretches of quiet space, their surfaces and interiors responding differently to the same gentle forces. As the mind rests with these four travellers, curiosity naturally turns toward the rings and smaller moons that share the same planetary realm, where similar processes of capture, formation, and slow transformation continue to play out. As the mind rests with these four travellers, curiosity naturally turns toward the rings and smaller moons that share the same planetary realm, where similar processes of capture, formation, and slow transformation continue to play out. One can picture the scene shifting gently outward from Jupiter's steady family to Saturn, another giant whose own companions have long invited the same unhurried attention. Here the light falls softer still, filtered through veils of ice and gas that stretch across vast distances, and the moons themselves seem to move with an even quieter grace, each one carrying its own subtle record of how worlds can linger side by side across ages measured in billions of years. Among these companions, Titan stands out as the most substantial, wrapped in an atmosphere thicker than Earth's own, and rich with the chemistry of distant beginnings. Its hazy envelope scatters sunlight into a gentle orange glow, creating a perpetual twilight at the surface where temperatures hover far below freezing, yet allow strange liquids to persist. Rivers of methane carve winding paths across the landscape, feeding broad lakes whose dark surfaces reflect the faint light like quiet mirrors. These bodies of liquid wax and wane with the slow seasons, evaporating into the thick air only to return as gentle rains that replenish the cycle. Observers have long wondered what further reactions might unfold in those sheltered pools, where complex organic molecules could gather and perhaps rearrange themselves over immense spans of time. The very presence of such stable liquid so far from the sun suggests that even in the coldest realms, pockets of activity can endure, sustained by the faint warmth trapped beneath the insulating haze. One lingers with the thought of dunes shaped by gentle winds and mountains of water ice rising above the methane shores, all held in a balance that feels both alien and strangely familiar, as though the moon offers a distant echo of processes that once shaped our own world in its youth. Farther in, closer to the planet's banded clouds, Enceladus moves through its orbit with a brightness that belies its small size. Its surface of clean water ice reflects sunlight almost like fresh snow, yet beneath that pristine shell lies a source of unexpected motion. At the South Pole, fractures open and close in a rhythmic pulse, driven by tidal stresses from Saturn and neighbouring moons, releasing plumes of water vapour and fine ice particles that arc high into space. These geysers do not erupt with violence, but rather feed outward in steady streams, supplying material to the faint E-ring that encircles the planet. Over countless orbits the particles spread and settle, tracing delicate paths that link the moon's interior activity to the larger architecture of the rings themselves. The heat that powers these vents remains modest, enough to keep a regional sea of liquid water in contact with a rocky core where minerals might dissolve and interact. Such an arrangement invites consideration of how chemical energy could circulate in these hidden reservoirs, far from any direct sunlight yet kept alive by the persistent gravitational embrace of the parent world. The process unfolds without haste, each eruption adding its quiet contribution to the ring's diffuse glow, a reminder that even the smallest bodies can influence their surroundings across long, untroubled intervals. Nearby travels Mimas, its face dominated by a single vast crater that gives the moon an uncanny resemblance to an ancient weapon from distant stories. The impact that formed this feature must have come close to shattering the little world entirely, yet the body endured, its icy crust healing over eons into the familiar pattern we now recognize. More intriguing still is the faint heat signature detected from within, a warmth that seems concentrated near the crater floor and cannot be fully explained by the gentle tidal flexing shared with other Saturnian moons. Some interpretations suggest residual energy from that ancient collision still lingers, slowly dissipating through the ice, while others propose subtle internal movements, or even a small irregular core that continues to shift. Whatever the source, the warmth remains too slight to melt the surface, yet sufficient to hint at ongoing hidden adjustment. One can imagine the moon as a quiet archive, its battered exterior preserving the memory of early violence, while its depths hold traces of a slower recovery, all within the same unvarying orbit that has carried it around Saturn for billions of years. Such details keep the curiosity alive, prompting further gentle questions about how impact scars and internal rhythms might coexist in bodies too small to have ever known geological upheaval on a grand scale. Then there is Iapetus, whose two-toned appearance puzzled observers for generations after its discovery. One hemisphere glows bright with clean ice, while the other lies darkened by a coating of reddish material whose origin long resisted simple explanation. Early telescopic views revealed the contrast clearly, yet the cause remained elusive until spacecraft measurements showed the dark terrain to be concentrated on the leading side, the face that ploughs forward through any tenuous dust in the system. Possible accounts include the gradual accumulation of particles ejected from other moons, perhaps Phoebe or smaller irregular bodies, that settle preferentially where they encounter the greatest resistance. Another line of thought considers thermal segregation, in which faint sunlight warms the surface enough for volatile ices to migrate and leave behind a darker residue that absorbs still more heat, reinforcing the pattern over time. Neither picture claims final certainty, yet both illustrate how slow external influences and internal responses can together sculpt a moon's appearance across vast stretches of quiet space. The boundary between the two hemispheres appears remarkably sharp in places, as though drawn by an invisible hand, and the overall effect continues to invite patient study of how seemingly minor differences in exposure can produce such striking results. Together these four companions, each distinct in scale, composition and history, form a loose yet coherent family around Saturn, their paths intertwined with the planet's rings and with one another through gentle gravitational ties. Titan's dense air and flowing liquids speak to the possibility of complex chemistry persisting in unexpected settings, while Enceladus demonstrates how interior heat can reach outward to sustain a surrounding ring. Mimas carries the visible scar of an early catastrophe alongside hints of lingering warmth, and Iapetus records the cumulative effect of dust and thermal processes on its divided surface. None of these features arose in isolation. All reflect the same long-term balance of formation, capture, and ongoing adjustment that characterizes the outer solar system. As one contemplates their steady circuits, the mind returns to the larger stillness in which they move, a stillness that accommodates both dramatic surface expressions and the most delicate, enduring interactions. The rings themselves, fed in part by Enceladus and shaped by the gravitational influence of these moons, extend the sense of quiet companionship further still, their icy particles orbiting in patterns that echo the moon's own unhurried rhythms. In this way, the Saturnian system offers a further invitation to linger with the thought of worlds that have remained neighbours across the entire span of recorded cosmic time. The processes at work here, atmospheric cycles on Titan, cryovolcanic venting on Enceladus, ancient impact aftermath on Mimas, and surface evolution on Iapetus, unfold at rates too slow for any single lifetime to witness, yet remain accessible through patient observation and thoughtful interpretation. Theories about hidden oceans, residual heat, or dust migration continue to evolve as new measurements arrive, each adding nuance without claiming to close the questions entirely. What endures is the impression of a realm where even the most unusual features belong to an overall pattern of calm persistence, one that encourages the same unhurried gaze once turned toward Jupiter's Galilean family. From this vantage, the outer solar system reveals itself not as a place of isolation, but as a gathering of companions whose individual stories enrich the shared narrative of gentle orbits and enduring quiet. As one lingers with the thought of those steady companions around Saturn, the gaze naturally widens to the rings themselves, those vast yet delicate structures that encircle the planet in layers of quiet motion. Far from the solid, unchanging bands they once seemed in early observations, Saturn's rings emerge as a realm of constant, gentle change, where particles shift and renew across timescales that stretch from mere decades to mere millions of years. Ice fragments, ranging from tiny grains to house-sized chunks, orbit in intricate patterns shaped by the gravitational pull of embedded moonlets and distant satellites alike. These shepherding bodies nudge the material into sharp edges and narrow gaps, yet the overall system remains temporary, with particles slowly spiraling inward under subtle drag or being scattered outward by passing comets and micrometeorites. The rings we admire today may trace their brighter, more visible form to a relatively recent disruption, perhaps the breakup of a small moon or the capture of icy debris from farther out, an event that refreshed the display without erasing the underlying architecture that has persisted in quieter form for far longer. Such renewal invites a sense of ongoing conversation between the planet and its surroundings, where what appears eternal from our vantage unfolds as a series of measured exchanges, each particle tracing its path in response to forces too faint to notice in a single human lifetime, yet decisive across the longer calm of the solar system. This same sense of layered, evolving stillness extends outward to Uranus, whose rings present an even more unexpected geometry. The planet itself rotates on its side, tilted nearly 90 degrees from the plane of its orbit, a configuration that may stem from an ancient collision or series of encounters that reoriented the world without disrupting its family of moons and rings entirely. As a result, the rings lie almost perpendicular to the ecliptic, appearing as narrow, dark threads when viewed from certain angles, and as broad, faint ellipses from others, composed largely of darker, dustier material than Saturn's bright ice. These rings nonetheless share the same principle of dynamic balance, held in place by small moons that orbit within or just outside the ring plane and prevent the particles from spreading too widely. The tilt itself creates seasons of extreme contrast, with one pole basking in decades of continuous sunlight, while the opposite endures prolonged shadow. Yet the rings persist through these cycles, their particles absorbing and re-radiating the faint energy in ways that maintain a tenuous cohesion. Observers have considered whether the rings originated from the same ancient upheaval that tilted the planet, or whether they formed later from captured cometary fragments, that settled into the equatorial plane after the rotation had already settled into its odd orientation. Either possibility leaves room for the rings to evolve gradually, their faint glow a reminder that even the most peculiar arrangements can settle into long-term companionship once the initial disturbance has passed. Moving still farther, Neptune's rings offer a subtler variation on the same theme, appearing as faint, incomplete arcs rather than full circles when first detected from Earth. These clumpy structures puzzle observers because the particles within them should, under ordinary orbital mechanics, spread evenly around the planet over time. Yet the arcs remain concentrated in specific segments, shepherded by the gravitational influence of nearby moons such as Galatea. The rings themselves consist of fine dust and larger icy bodies, far fainter than those of Saturn or even Uranus, suggesting either a younger system still in the process of organizing or an older one continually replenished by impacts on small inner moons that release fresh material into the orbital paths. The mystery of the clumps invites gentle speculation. Perhaps resonant interactions with the moons create temporary traps where particles linger longer before leaking away, or perhaps unseen kilometre-scale moonlets embedded within the arcs provide the necessary gravitational scaffolding. In either case, the structures speak to a balance that is both fragile and persistent, one in which the rings neither fully dissipate nor achieve perfect symmetry, instead maintaining their distinctive patches through ongoing, low-level exchanges that echo the same unhurried processes seen closer in. Across these varied systems, the question of ring formation itself unfolds as a story of shared origins and gradual transformation. Most rings appear to arise from the disruption of small bodies, moons, comets, or even passing asteroids, whose fragments are captured into orbit and then ground down by mutual collisions into the fine particles and larger chunks observed today. The material is predominantly water ice in the colder outer reaches, with traces of rock, dust, and organic compounds that darken the rings of Uranus and Neptune, while leaving Saturn's brighter and more reflective. Once formed, the rings do not remain static. Micrometeorite bombardment slowly darkens the ice, while Poynting-Robertson dragon interactions with the planet's magnetic field cause particles to lose orbital energy and drift inward over millions of years. At the same time, fresh material continues to arrive from the occasional disruption of a nearby moon, or from geyser activity on active satellites, replenishing what is lost. Eventually, without sustained sources of renewal, the rings would fade as their particles either fall into the planet's atmosphere or accrete into new small moons, closing one chapter and potentially opening another in the long cycle of satellite and ring evolution. This turnover, measured in tens to hundreds of millions of years for the brightest examples, underscores how even the most striking features belong to an overall pattern of quiet persistence rather than fixed permanence. One can picture the scene shifting outward from Saturn's more familiar architecture to these more distant expressions, where the same gentle forces play out under different lighting and at greater remove from the Sun. The rings of Uranus and Neptune, though less conspicuous, extend the narrative of companionship by showing how tilted rotations and resonant clumps can coexist with the same underlying principles of capture, grinding, and slow dispersal. Theories about their precise ages remain open, with some interpretations favouring recent origins tied to captured objects, and others allowing for ancient rings that have simply been maintained at lower densities through steady replenishment. What remains consistent is the impression of systems that accommodate both dramatic initial events and the most delicate ongoing adjustments, all within orbits that continue without haste across billions of years. As the mind rests with these ringed worlds, curiosity turns naturally toward the still more distant moons that accompany them in the outer darkness, where similar stories of formation and quiet endurance continue to unfold. Yet beyond these ringed sentinels, attention drifts farther still into the outer darkness, where the same unhurried forces that shape delicate arcs and tilted planes continue to arrange smaller worlds in patterns that feel almost companionable in their persistence. One lingers first with the moons of Uranus, a family whose names echo the plays of Shakespeare and thus carry a quiet literary resonance across the void. Miranda, with its fractured surface suggesting ancient upheavals now long settled into equilibrium, orbits close enough to feel the planet's gravitational embrace, yet far enough to maintain an independent path marked by gentle tidal flexing that may once have renewed its icy crust without erasing the scars of earlier encounters. Ariel and Umbriel follow in their own measured circuits, the former bright with fresher ice and the latter darker, their contrasting tones hinting at divergent histories of resurfacing or the slow accumulation of external dust that never quite disrupts the steady rhythm they share with Titania and Oberon farther out. These 5 larger bodies, together with a host of smaller attendants, trace orbits that remain remarkably regular despite the planet's extreme axial tilt, prompting quiet consideration of whether they formed alongside Uranus or arrived later through capture and subsequent circularization, their present arrangement offering a window onto processes that unfolded across eons without haste or dramatic interruption. Theories suggest that an early collision capable of tipping the planet could have scattered material into temporary rings or disks from which some of these moons coalesced, while others may represent fragments that survived and settled into the equatorial plane once the initial disturbance faded, leaving behind a system whose apparent stability masks an underlying story of gradual accommodation rather than sudden creation. This same outward progression leads naturally to Neptune, where Nereid traces one of the most elongated paths among the major satellites, its orbit stretching and contracting in a manner that evokes a long, untroubled wander through the faint sunlight at the system's edge. Unlike the tighter, more circular routes of closer companions such as Triton, Nereid's extreme eccentricity invites speculation that it may once have moved on an independent trajectory through the scattered disk before gravitational encounters drew it into Neptune's influence, a capture that left it swinging from distances comparable to those of irregular satellites, yet still bound within the broader family. The elongated motion itself becomes a study in quiet endurance, as the Moon experiences varying tidal stresses that never quite overcome the overall cohesion of its icy composition, allowing surface features to persist across timescales that dwarf human history. Observers have wondered whether additional unseen bodies or resonant interactions with smaller moons help stabilize this unusual path, preventing it from drifting away entirely or plunging inward, and such possibilities underscore how even the most eccentric arrangements can settle into long-term companionship once the initial perturbations subside. In this way, Nereid extends the narrative of evolving stillness already observed among the rings, demonstrating that capture and subsequent adjustment operate across a wide range of orbital scales without requiring perfect symmetry or immediate finality. Farther still, beyond the ice giants, the Kuiper Belt offers its own version of measured companionship in the form of Pluto and its largest moon Charon, whose mutual orbit resembles a binary dance rather than the more conventional planet-satellite hierarchy found closer in. The two bodies circle a common centre of mass that lies outside Pluto itself, their gravitational embrace creating a rhythmic exchange of tidal forces that may have once heated their interiors enough to allow cryovolcanic activity or resurfacing before cooling into the present state of frozen equilibrium. Charon's relatively large size compared with Pluto invites gentle inquiry into whether the pair originated from a single progenitor, disrupted by an ancient impact, with the resulting fragments settling into their current locked rotation that keeps one face of each body always turned toward the other. As they travel together through the sparse population of the Kuiper Belt, occasional encounters with smaller objects or resonant influences from Neptune may nudge their shared path without ever fully disrupting the quiet stability they have maintained for billions of years. This binary configuration sparks curiosity about how such systems form and endure at the solar system's periphery, where lower densities of material allow for gentler interactions and longer preservation of primordial features, reminding one that the outer darkness preserves not only distant orbits, but also alternative architectures of companionship that differ markedly from those nearer the Sun yet follow analogous principles of capture, adjustment, and persistence. Scattered among these larger examples are the small irregular moons that accompany the gas and ice giants, their distant, often retrograde paths offering clues to the broader migrations that once reshaped the solar system. These bodies, typically only kilometers across and dark with organic-rich surfaces, move on highly inclined and eccentric trajectories that suggest they were captured from the population of planetesimals or comets drifting through the early disk rather than forming in place around their present hosts. The very irregularity of their orbits becomes a record of past dynamical events, as gentle gravitational scattering during the migration of Jupiter, Saturn, Uranus, and Neptune could have drawn such objects inward from the trans-Neptunian region and temporarily trapped them before further encounters either stabilized or ejected them. One contemplates how these modest attendants, too faint and distant to have been detected until recent decades, nonetheless illuminate the fluid, early architecture of the outer planets, when resonances and close passages redistributed material across vast distances without erasing the underlying calm that now prevails. Theories of Nice model migrations or earlier chaotic phases allow for multiple episodes of capture and release, each leaving behind survivors whose present quietude speaks to the damping of those ancient excitations over subsequent gigayears. In their modest way, these irregular moons extend the same sense of ongoing conversation between planets and their surroundings that appears among rings and regular satellites alike, showing how even transient captures can evolve into enduring, if eccentric, relationships once the larger system settles. Taken together, the moons of the outer darkness weave a continuous thread with the rings and closer satellites already considered, each contributing its own variation on themes of capture, tidal evolution, and gradual renewal within an environment where sunlight is faint and timescales stretch comfortably beyond immediate perception. The Shakespearean family around Uranus, Nereid's elongated circuit, the binary rhythm of Pluto and Charon, and the scattered irregular attendants all invite reflection on how diverse formation pathways, whether in situ accretion, collisional disruption, or distant capture, can converge on stable configurations that persist through the gentle influence of resonances and distant perturbers alike. Curiosity naturally deepens at the thought of yet undiscovered bodies in these remote regions, where similar processes may still operate unseen, preserving records of the solar system's youth while participating in its present unhurried equilibrium. Such contemplation returns the mind to the overarching pattern of quiet companionship that links the innermost rings to the farthest orbits, underscoring how every distant moon, however small or oddly placed, adds its measured voice to the larger conversation, unfolding across the calm expanse. Beneath these varied arrangements lies a set of physical principles that allow the solar system's outer companions to maintain their measured rhythms across vast stretches of time, principles that turn potential chaos into something resembling quiet companionship. One begins with the Lagrange points, those 5 special locations where the gravitational pulls of a planet and its star balance in such a way that smaller bodies can linger with little expenditure of energy. Discovered through the mathematical insight of Joseph Louis Lagrange in the late 18th century, these points offer stable or semi-stable parking spots. The L4 and L5 positions, 60 degrees ahead of or behind a planet in its orbit, act as gentle gravitational wells where material can accumulate over eons, while L1, L2, and L3 provide more fleeting vantage points along the line connecting the 2 larger bodies. In the outer solar system, these equilibria help explain the presence of small, irregular moons or captured objects that drift near the edges of planetary influence, without immediately escaping or colliding, their long-term residence made possible by the same subtle balance that keeps Trojan asteroids sharing Jupiter's path. One wonders whether additional undiscovered bodies might yet occupy analogous positions around Uranus or Neptune, their faint signatures awaiting detection by instruments sensitive enough to distinguish them from background starlight, thereby extending the catalogue of places where motion slows into something almost stationary relative to the primary world. From these fixed points, the conversation naturally turns to orbital resonance, the rhythmic locking that allows moons to keep time with one another across billions of years. When the orbital periods of 2 or more satellites fall into simple integer ratios, their gravitational tugs reinforce rather than cancel, producing a steady synchronization that can persist long after the original conditions that formed the system have faded. The Galilean moons furnish a classic illustration, with Io, Europa, and Ganymede locked in a 1 to 2 to 4 resonance that maintains their eccentricities and drives the internal heating responsible for Io's volcanism and Europa's subsurface ocean. Yet the same principle operates more quietly among Saturn's smaller attendants and even among the irregular satellites of the ice giants. Over immense timescales, these resonances act as governors, damping random motions and guiding captured bodies into configurations where close approaches recur at predictable intervals, rather than scattering them outward. Theories suggest that many of the outer moons reach their present resonant states only after prolonged migration and circularization, the initial capture events giving way to gradual adjustments that left behind the orderly sequences now observed. Such synchronization invites gentle curiosity about whether similar hidden resonances still operate among the smallest, least studied members of the Kuiper belt, where lower masses and greater distances might allow even more delicate commensurabilities to endure without ever producing dramatic surface activity. Closely allied to resonance is the phenomenon of tidal locking, the process by which gravitational gradients slow a satellite's rotation until one hemisphere permanently faces its parent body. Most of the major moons discussed thus far, from Earth's own companion through the Galilean satellites to Charon and the larger Uranian attendants, exhibit this same face orientation because the tidal bulge raised on the Moon by its planet exerts a torque that transfers angular momentum until spin and orbital periods coincide. The result feels almost companionable. An observer standing on such a moon would see the parent planet hanging motionless in the sky, while the distant sun and stars wheel slowly overhead. Yet tidal locking need not be instantaneous or perfect. Smaller moons, or those on highly eccentric paths, can experience only partial synchronization, their rotation rates librating around the mean motion in a manner that still preserves an overall stability. One contemplates how the same mechanism that keeps our moon's familiar face turned toward Earth also operates across the faint light of the outer solar system, where lower temperatures and reduced tidal forces stretch the timescale for locking into ranges that comfortably exceed the age of the solar system itself. This invites reflection on whether some of the irregular satellites, still rotating more freely, represent bodies captured too recently for full locking to have occurred, their present spin states serving as quiet records of the moment they entered planetary service. The graceful ellipses traced by these worlds further illustrate the underlying physics of quiet endurance. While idealized circular orbits provide a convenient approximation, real paths are elliptical, with the central body offset from the geometric center according to Kepler's laws. Moderate eccentricity allows a moon to experience varying distances and therefore varying tidal stresses, flexing its interior gently enough to dissipate energy without fracturing the surface or ejecting material. Nereid's elongated circuit around Neptune exemplifies this tolerance, its orbit stretching and contracting, yet still remaining bound within a system whose overall architecture damps extreme excursions. In contrast, near-circular paths such as those of the regular Uranian moons minimize such variations, producing the steady tidal environment that permits long-term preservation of ancient surface features. Orbital eccentricity itself can be maintained or amplified by resonances, as seen in the Galilean system, or it can slowly damp through interactions with rings or residual disk material, leaving behind the nearly circular routes now common among the inner satellites of Saturn. Theories of early dynamical evolution suggest that many of today's eccentric orbits began with even greater elongations following capture or scattering events, only later relaxing into the calmer ellipses that characterize the present epoch. This progression from excited to settled motion underscores how the solar system's architecture favors persistence once initial perturbations subside, allowing even oddly placed bodies to participate in the larger conversation of gravitational balance. Taken together, these principles, Lagrange equilibria, resonant synchronization, tidal locking, and elliptical tolerance, form the quiet scaffolding that supports the diverse arrangements encountered from the inner rings outward to the Kuiper belt. They operate without haste, their cumulative effects unfolding across timescales that render human history negligible, yet they remain accessible to patient observation and mathematical description. One returns repeatedly to the thought that the same forces shaping the stable parking spots near Jupiter also guide the synchronized steps of distant moons and the gradual circularization of captured objects, weaving a single fabric of measured companionship across the entire solar system. Such contemplation deepens the sense of an unhurried cosmos in which apparent irregularities often conceal deeper regularities, inviting continued attention to regions where faint signals might yet reveal additional instances of these enduring patterns. Yet even within this architecture of measured companionship, certain orbits stand apart, their paths revealing histories of disruption and capture that once shook entire regions of the forming solar system, before settling into patterns still governed by the same patient forces. Retrograde motion, for instance, where a moon circles its planet opposite to the primary direction of rotation, speaks of bodies likely seized from independent trajectories rather than born alongside their hosts. Such reversals imply encounters intense enough to reverse angular momentum, perhaps through close gravitational scattering with larger intruders, or the slow drag of an ancient gaseous envelope that spiraled material inward until orbits flipped and stabilized. One contemplates how these backward travelers, now found among the irregular satellites of Jupiter, Saturn and Neptune, have since quieted into long-term residence, their inclinations steep and their periods extended, yet still locked within the broader gravitational embrace that prevents escape into the wider heliosphere. Theories of early solar system violence suggest these captures occurred amid a denser population of stray planetimals, each event etching a record of chaos that later resonances and tidal effects gradually softened, leaving behind the present-day wanderers whose faint light reaches us as quiet testimony to an older, more turbulent epoch. From these reverse circuits the mind turns naturally toward bodies whose own spins defy simple prediction, as with Saturn's moon Hyperion, whose irregular potato shape and porous interior produce a tumbling so chaotic that no single face remains oriented toward its parent for long. Rather than the steady tidal locking seen elsewhere, Hyperion rotates in a manner sensitive to tiny perturbations, its spin axis wandering unpredictably across timescales of days to weeks, a motion first clarified through careful tracking of its light curve and later modelled as a classic case of chaotic dynamics within the restricted three-body problem. This tumbling does not disrupt the Moon's overall orbit, which remains bound and elliptical in the usual sense. Yet it ensures that any future surface explorer would experience a constantly shifting horizon, with Saturn's banded face rising and setting at irregular intervals while the distant Sun traces unpredictable arcs. One wonders whether such internal disorder preserves ancient ices and organics better than tidally locked worlds, shielding volatiles from repeated heating cycles and allowing Hyperion to serve as a preserved fragment of the early Kuiper belt material that once drifted freely before planetary encounters drew it inward. The same orbital mechanics that permit this chaos also guarantee long-term stability, demonstrating how even extreme rotational states can coexist with the unhurried companionship of the outer system. Extending outward beyond our own solar system, the 7 planets orbiting the ultra-cool dwarf star TRAPPIST-1 offer another illustration of how resonant chains can organize compact architectures into enduring harmony despite their proximity to one another. Here the planets lie so close that a year on the innermost world lasts scarcely a few Earth days, yet successive pairs fall into integer-period ratios that lock their motions into a synchronized rhythm, much like a miniature version of the Galilean arrangement, but scaled to an entire system of rocky worlds. This tight packing invites speculation about migration histories in which the planets formed farther out and spiraled inward together, their mutual gravitational tugs preserving commensurabilities that would otherwise have led to collisions or ejections. One contemplates the possibility that such resonances act as a protective lattice, damping eccentricities enough to maintain temperate conditions on several of the worlds, and perhaps allowing liquid water to persist beneath thin atmospheres or within subsurface reservoirs. Although direct evidence remains limited to transit timings and radial velocity hints, the configuration itself suggests an unhurried evolution, in which initial dynamical excitement gave way to the present orderly sequence, a reminder that even around distant stars the same principles of orbital balance can foster stability across billions of years in environments far removed from our own. These same principles of orbital mechanics, refined through centuries of observation and calculation, continue to guide the trajectories of spacecraft that traverse the solar system on voyages spanning decades. Gravity assist maneuvers, first demonstrated with precision during the Voyager encounters, allow a probe to steal a fraction of a planet's orbital momentum, bending its path and boosting its speed without expending additional propellant, thereby transforming what would be an impossibly long coast into a feasible itinerary from one world to the next. One envisions the careful sequencing of these flybys, each timed so that the spacecraft arrives at a precise angle and velocity, its hyperbolic trajectory relative to the planet converting into a new heliocentric ellipse that reaches farther or swings inward as needed. Such techniques have enabled missions to sample the atmospheres of Venus, to image the rings of Saturn from novel vantage points, and to rendezvous with distant comets whose orbits intersect only after years of patient cruising. Theories of optimal trajectory design continue to evolve, incorporating low-thrust ion propulsion alongside traditional assist to open routes toward the ice giants or even interstellar space, yet the underlying mathematics remains rooted in the same Keplerian ellipse and resonant opportunities that govern natural satellites. In this way, the quiet study of moons and their extremes becomes practical knowledge, turning contemplation of retrograde captures and chaotic tumbles into tools that extend human presence across the solar system's vast distances. As one reflects on these varied cases, from the violent origins implied by reversed orbits to the unpredictable spins of porous moons and the compact resonances of faraway planetary systems, a deeper appreciation emerges for the flexibility inherent in gravitational order. What first appears as anomaly often resolves, upon closer inspection, into another expression of the same balancing forces that maintain Lagrange points and tidal locks across greater timescales. The spacecraft journeys themselves become extensions of this pattern, their engineered paths borrowing from the natural choreography of captured satellites and resonant chains to achieve ends that once seemed reachable only through extravagant expenditure of energy. One returns to the thought that the solar system, and the wider cosmos it samples, favours persistence even amid apparent disorder, allowing extremes to coexist with the measured rhythms that invite continued observation and gentle curiosity about what further irregularities may yet come to light in the faint reaches beyond our present instruments. As we draw these measured hours to their gentle close, one returns once more to the thought that the solar system, and the wider cosmos it samples, favours persistence even amid apparent disorder. The moons we have lingered beside, from the familiar face of our own companion to the captured wanderers circling Jupiter and Saturn, the resonant chains binding the Galilean family, and the distant icy bodies drifting in the outer darkness, all speak of the same unhurried forces that shape rings into quiet arcs and hold orbits in patient balance. We have travelled together through these vast, quiet beauties, pausing to consider how retrograde paths record ancient captures, how chaotic tumbles preserve ancient ices, and how resonant lattices across distant stars may yet shelter conditions for liquid water beneath thin atmospheres. Each of these scenes invites continued observation, each pattern reminding us that extremes and measured rhythms coexist without contradiction, their stories still unfolding in the faint light that reaches us across billions of years. Yet even as these reflections settle, endless questions remain waiting for answers. What further irregularities might surface missions reveal on the porous surface of Hyperion or beneath the frozen crust of Europa? How might refined models of early migration reshape our understanding of TRAPPIST-1's compact worlds, or of the subtle gravitational assists that guide probes ever deeper into the heliosphere? Theories of solar system formation continue to evolve with each new transit timing and light curve measurement, leaving room for interpretations that honour both the observed resonances and the possibility of undiscovered planetesimal encounters. One wonders what additional retrograde travellers or tumbling fragments await detection by instruments still years from launch, their faint signatures perhaps already embedded in archival data from spacecraft that borrowed momentum from the very planets they once flew past. These open inquiries do not diminish the quiet order we have explored. Instead, they extend its invitation, encouraging the same gentle curiosity that has accompanied us through the ringed giants and the shadowed outer reaches. Thank you for sharing these hours of wonder with us, for allowing the calm rhythms of moons and orbits to accompany your own quiet moments. Your presence has made this long journey through the cosmos feel less like solitary contemplation and more like a shared drift among familiar companions. If the content here has offered a measure of peaceful interest, subscribing will help you find more such explorations whenever new sections become available, guiding future voyages toward topics that continue to spark the same thoughtful engagement. We would also be grateful if you would take a moment to comment and let us know where you are listening from, whether from a quiet room at dawn, a late-night drive, or any corner of the world where these facts about distant satellites find a receptive ear. Your thoughts and suggestions help shape what comes next, ensuring that each return to the quiet universe remains as engaging and curiosity-filled as this one. Until we meet again among the measured paths of yet another set of silent worlds, may the same patient forces that steady the Galilean dances and soften the chaos of tumbling moons continue to offer you a sense of enduring balance. The cosmos remains vast, its questions patient, and its quiet beauties always ready to welcome a returning mind.